At problem 6, section 4-5, evaluate the definite integral if it exists 0 to pi over 3 negative 7 sine x over cosine squared x dx. If the integral does not exist, type dne. Look, 0 to pi over 3, cosine is not 0. Alright, cosine becomes 0 at pi over 2. So this is a valid domain for this expression. So integral will exist. Okay, so let's figure out what it is. That's my question. So since this is definite integral, we need to find an antiderivative and then evaluate the antiderivative at the limit points. Okay, so to find its integral, we need a method of substitution. So let u equals cosine x. Now, since this is definite integral, you need to worry about the limits as well. When x is pi over 3, plug in pi over 3, u equals cosine pi over 3, that is half. When x is 0, plug in x equals 0, u is cosine of 0, that's 1. When u is cosine x, du dx is negative sine x, which is good. I have sine x. So, negative sine x dx is du. So, this brings me, definite integral gives me a definite integral. x0 corresponds to u1. X pi over 3 corresponds to u half. 7 stays put. Negative sine x dx, negative sine x dx is all du. Cosine squared x is u squared. Alright? So this integration is easier now. You have 7 u to the power negative 2 du. Limits 1 to half. Find its antiderivative, so plus 1 plus 1. Limits are 1 to half. So 7u to the negative 1 over negative 1, limits 1 to half. Negative, positive upstairs, negative downstairs is an overall negative. This negative power of u comes down, becomes positive power. So all of this becomes negative 7 over u, limits 1 to half. What do these limits mean? We have found our antiderivative. Now evaluate it in the upper limit minus evaluate it in the lower limit. So wherever you see u, place half. Wherever you see u, place 1. Okay, and then you take the difference. Notice the negative. Keep track of the signs. Division by a fraction is multiplication by the reciprocal. So the first term is negative 2 over 1 times 7 over 1. The second term, negative inside and a negative outside. So that's a positive 7. Negative 14 plus 7 is negative 7. Okay. So this is negative 7. Submit. Alright. Next problem. Evaluate the integral. This is again a definite integral 0 to 9 negative 3 2x minus 9 power 25. Okay. Since this is definite integral, we need to find antiderivative, then evaluate the antiderivative at the limit points. Okay. So this looks like a good sample for the new variable u. U equals 2x minus 9. When x is 0, plug it in, u is negative 9. When x is 9, plug it in, u is 18 minus 9, 9 again. What about du dx? Du dx is 2. Derivative of this guy is 2. In other words, du over 2 is dx. All right. So my original question is in 0 to 9, integral 0 to 9, negative 3, 2x minus 9, power 25 dx. That is negative 9 to 9. So do you see how I got the negative 9? When x is 0, u is negative 9. So align the limits. When x is 9, u is 9. Negative 3, negative 3. U to the power 25. U to the power 25. Dx is du over 2. All right. But notice this is negative 9 to 9 of an odd function. If I have an odd function and symmetric limits, then that integral is 0. Okay? If you don't remember why, go to the picture, go to the lecture slides and let me show you what I mean. See the topic on symmetry. Okay, it's on page 16. For a quick recap, if you have an odd function, part of it will be above and precisely the same amount is below. So they cancel each other. So if you have symmetric endpoints, for an odd function, the integral is 0. Okay, so that's what has happened. This is an odd function. Look, odd power and nothing else. Symmetric endpoints, so this is 0. All right. So next problem, next slide, next video. Okay. Until then.